Well, hello, AP Statistics students. Mr. Eicher here, cozying out in my t-shirt upstairs in my house, coming at you with a 2012 number 4 inference question. Let's look at this one. If you haven't read the question, feel free to pause the video and you could read this. Some important information. You have two separate groups. You have a sample in 2008 of 1,009 US adults. You had a sample in 2007 of 1,020. And notice that we don't have means. There are no means here. There are no standard deviations here. There's no two-way table here. Notice we just have counts of how many people out of the total. So basically what we're provided here is a p-hat of 622 over 1020 and a p-hat of 676 over 1009. Also, if you weren't sure, if you read closely, you can see the word proportion is a really good clue that we'll be using proportion information. Because of that, let's check out the formula sheet. This is the second page of the formula sheet. We mentioned proportions, and hey, here it is, sampling distribution of proportions. And we have two groups, so we're in this row right here. And we're going to do a significance test, and we're going to be assuming that the two population proportions are equal. So we need to find, eventually in the problem, the combined proportion, p hat c. And we're going to be using this formula for our standard error of the statistic. So you keep those in mind, but that's what we're going to be doing. That's what we're going to be using. So let's jump back here. A couple other things you're asked, do the data provide convincing evidence? That is a clue that you need to do a significance test. If you wanted to do a confidence interval could work here. You'd have to include the hypotheses, which you might not think to do. But typically with confidence intervals, you'll be told construct and interpret a confidence interval. So we're going to do a test instead. The last thing I want to point out is this word changed. That is telling us this is a double-sided test, and we're going to use a not equal to in our alternative hypothesis. So let's check out the hypotheses. One last thing. I do want to point out that on this question, big blank page, remember we have a 4-step process. So it might help if you're on the paper exam to draw 4 quadrants. We're going to have our hypotheses, we're going to check our conditions, we're going to actually do the calculations, and then we're going to conclude. However you remember those 4, really important that you get all those, because basically you get a point, roughly, you get a point for each section. Okay, so here are our hypotheses. So we have the null hypothesis is always equal to, and when we have a difference between groups, it's equal to 0. Notice I did not put p-hats here. We're not interested in the difference in sample proportions. We already know that difference. We'd like to know the unknown proportion, the population proportion. And it's not enough just to write this. You have to define what these proportions are. So that's what I did over here. I did it in 2 different ways. You could define them separately. So you could do it like this. That's a lot of writing and a lot of kind of repeating what you just said type of writing. You could define it all at once, defining the difference between the proportions, and then you just have this, and I don't know, a little less writing. A couple things to point out. I really like the term unknown difference in proportions, or the population difference in proportions. You definitely don't want to say the sample difference, or the difference in sample proportions. That would be a big issue. You'd lose points. I also mentioned all US adults, since we're referring to a population parameter. And then lastly, when you're defining your parameter, you really need to use present or future tense. So I've used would respond, not the proportion who responded, past tense, but who would respond, since it's unknown. So that's our first step, writing the hypotheses. So that's it right there. The next step, we'll check conditions. So that's what we have over here. Checking conditions. Just to point out, from the 2008, we had 67%. That's this number divided by this number. And then in 2007, we had 61%. So it looks like we have some initial evidence here that there is a change, but we're wondering, is that change due to sampling variability? Or maybe that change is due to the fact that it actually has changed over the years. So I need to identify what test you're using. We have two proportions, and we always use a Z test statistic with proportions. So it's a two proportion Z test. We have count them, two random samples. That plural there is really important. If you just said random sample check, you would not get full credit because we need two random samples. We check the 10% condition for independence. Since we're sampling without replacement, you really don't have true independence, but we can ignore that issue as long as the population is very large, and the population of the US, we're assuming, is bigger than that, and it definitely is bigger than that for both years. You do have to check that for each individual sample. So take your sample size times 10, add a 0 at the end, and you get that. I'm going to do the normal condition at the end because it takes the longest and it's the most unique. Really, for whatever test you do, random, independent, and this G down here are going to be basically the same for the different multiple group significance tests that we have. But we just mentioned here the two groups are independent. This isn't paired data, this is independent data. So how do we check the normal condition? Well, we need p hat c, and I showed you the formula sheet earlier. P hat c, we have our combined successes, total number of successes here, divided by our total sample sizes. We're doing this because we're assuming the two population proportions are really equal to each other from the null hypothesis. And if they're equal, we might as well throw everybody in one bucket and count one single proportion of 64%. And we use that 64% when we check the condition. So we use it in each of these. Again, this is n times p hat c is greater than or equal to 10. And we're doing that here and here. And this bottom one here is n 1 minus p hat c. So that's the formula. That's not provided on the formula sheet, but that's how you check that condition. And there's my greater than or equal to 10 for each of these. At that point, it's really nice if you could state this, but that would be kind of a smiley face if you can state that correctly. I'd caution you, though, if you're going to state something like that, it is the sampling distribution. It's not sample, but the sampling distribution. And it's a distribution of the statistic. The statistic varies, the parameter does not vary. And it's approximately normal. So there's a lot of landmines here if you're going to make a statement like this. I'd be really impressed if you said that correctly. I'd be proud. But again, students often use the wrong word here, or they use the wrong statistic, or they forget to say approximately. So I would probably just leave it at this and then just say this condition is met. So those are our conditions. The next step, we're actually going to calculate the test statistic and p-value. So that's what we have over here. We have a two proportion z-test is what we're going for. From the formula sheet, if you don't remember the test statistic formula, here is the general test statistic formula. It's a z-score basically. Statistic minus the null over the standard error of the statistic. The general formula is right here. Our statistic is the difference in sample proportions. And we're using the p hat c in our standard error formula. Plugging the numbers in, we get this. Now I've rounded these numbers, 67 and 61, a little bit. I've also rounded these numbers to the nearest hundredth. So our test statistic of 2.91 is close enough, but it isn't entirely correct to the hundredth or whatever, but we'll see that later. And then once you have the test statistic, we can plot it. We just calculated or showed the normal condition. So we have a normal curve, but our 2.9. It's double-sided though, so you need the other side as well. And then from there, we can calculate the p-value doing 2, since we have two tails, times 2 times normal CDF. Here are the inputs, and we get a p-value of 0.0036. Now, that's using the massive formula. I probably would suggest staying away from that unless you're really confident that you got your numbers right. I'd probably save time and mistakes if you just use your calculator to do a 2-prop z-test. That's under Second Stat. Scroll over to Tests. And on my calculator, it's number 6, 2-prop z-test. You're going to put in your X number of successes from 2018. That was 676. Your sample size is 1009. And then 2017 was next. There we go. It's really important that you're consistent. In my hypotheses, I had started with 2018 and then 2017. You could very well switch those in the hypothesis, but if so, you're going to have to switch them here. Now, if you didn't do that, your test statistic is going to have the wrong sign. So our test statistic should be 2.82. That's the exact test statistic. The one that I had earlier, due to rounding, that's why the difference is there. And our exact p-value is 0.0048. Maybe I shouldn't say exact, but the calculator gives the more accurate p-value compared to the one that I had earlier. But either one of those would be accepted. So if you decide to do this approach on the AP exam, you definitely need to name the test and you need to state the z and the p-value. All of this stuff is helpful for you, but not particularly helpful to the person reading your response. They're not really going to pay attention to that. They would see, did you get the test statistic and p-value? Did you name the test correctly? If so, moving on. Last step, we have to conclude in context. So we have our explicit comparison of our p-value with the alpha level. I use the p-value from the formula, so this p-value is slightly different than the calculator p-value. We have a statement about the null hypothesis. We're rejecting the null, and this gives us convincing evidence that, and then I copied this pretty much verbatim just to make sure I got the correct context. Again, remember to use future tense or present tense when concluding in context. What type of error might we have made? We may have made a type 1 error. We might think that it has changed. We found evidence that it has changed, but the evidence led us astray. In reality, there is no change in the proportion of US adults who would answer this question. Thank you for watching this video. If you have any questions, feel free to reach out and ask me. Good luck on the AP exam. See you next time.